Okay, so if you're a Java developer, you know the routine, right? You build your app, you package it up, and then the real headaches start with deployment. But what if there's a better way? Today, we're going to dive into how Docker completely changes the game for how you package, deploy, and scale your applications. Let's get right into it. The difference here is really like night and day. On one side, you've got the old way, traditional virtual machines. They're slow, they're heavy, and they're the reason we all have to say, but it works on my machine. And on the other side, you've got containers, fast, lightweight, and portable. Docker was literally built to solve this exact problem. And honestly, for us developers, it's a massive, massive leap forward. All right, so before we can really appreciate the solution, I think we have to properly understand the pain. Let's just take a quick trip down memory lane and talk about the world of virtual machine deployments. I bet these problems feel super familiar. VMs take forever to boot up. We're talking minutes, because they have to load an entire guest operating system. That creates a ton of overhead, which really limits how much stuff you can run. But the biggest headache of all, the one that drives us crazy, has always been that impedance mismatch. That soul-crushing moment when your code works perfectly on your laptop, but then it just completely breaks in production because of some tiny difference in the environment. Ugh. So how do we fix all this? Well, this is where Docker comes in. And it's not just a small improvement. It's a completely new and much better way to think about building and deploying our software. As Java developers, this phrase is pretty much in our DNA. The original promise of Java was that our compiled bytecode could run on any machine that had a JVM. And that was revolutionary, right? It abstracted away the underlying operating system for our code. And this is the promise of Docker. It takes that original idea from Java and just blows it up. It's not just about your code anymore. We're talking about the entire application. Your code, all its dependencies, libraries, even the configuration files, all of it gets bundled into one single unit that can run absolutely anywhere. It's the evolution from write once, run anywhere, to package once, deploy anywhere. So what even is a container, really? Well, think of it like this. It's a super lightweight, totally isolated sandbox just for your app. It has everything your application needs to run, but, and this is the key, it shares the host machine's operating system kernel. That is the secret sauce. That's what makes it so much faster and way more efficient than a full virtual machine. The whole Docker workflow really breaks down into 3 simple steps. First, you build a read-only template of your application, and we call that an image. Second, you ship that image up to a central registry, something like Docker Hub. And third, you run that image to create live containers that you can start, stop, and scale. Build, ship, run. It's a simple loop, but it's incredibly powerful. Okay, so we just talked about that build, ship, run cycle. Let's zoom in a little bit on that first step, build, and really look at the heart of it all, the Docker image. A Docker image is a read-only template, but the real magic is in its structure. It's actually made up of a series of layers, all stacked on top of each other. So when you update your application, you don't rebuild the entire thing, you just add a new thin layer on top. This is why Docker is so fast. Distributing an update just means sending that one tiny new layer, not a whole new multi-gigabyte virtual machine. It's a game changer. And how do you create these images? With a simple text file called a Docker file. And look, this is about as basic as it gets. The from instruction tells Docker to use a pre-existing base image, in this case, one that already has Java installed. Easy. Then, the cmd instruction just specifies the default command to run when a container starts. Here, we're just asking it to print the Java version. See? Simple. Of course, in the real world, you're going to use a few more commands than just those 2. From sets your base layer. Copy is how you get your files, like your .jar or .war file, into the image. Run executes commands during the build process, maybe to install a package. CMD sets the command to run when the container actually starts up. And expose is there to document which network ports the container is going to listen on. These are basically the essential building blocks for any Java application's Docker file. Okay, so a single container is great and all, but let's be real. Real-world applications are rarely that simple. They usually have a lot of different moving parts. So the next logical question is, right, what if my application needs, say, a Wildfly application server and a Couchbase database? Do I just cram them both into the same container? The answer is a hard no. That's a bad idea. You run them in separate containers. So how do you manage them together? The answer to that question is Docker Compose. It's a tool specifically for defining and running your entire application stack, your web server, your app server, your database, the whole shebang, all from a single configuration file. Its superpower is making these complex, multi-service applications incredibly easy to spin up on your local development machine. With Docker Compose, managing your entire stack becomes, well, trivial. With just one command, Docker Compose up, you create and start everything. Docker Compose stop shuts it all down nice and clean. What used to be this really complex setup process is now just a single repeatable command. It's amazing. So we have our multi-container app running beautifully on our local machine. Awesome. But what about production? Because running everything on just one machine in production is pretty much a recipe for disaster. Yeah, exactly. If you run all your containers on a single host machine, that machine becomes a single point of failure. If it goes down, your entire application goes down with it. And that is just not acceptable for any serious application. The solution to this problem is something called orchestration. This is the whole process of automatically managing, scheduling, and scaling your containers across a whole cluster of machines. Orchestration is what handles things like high availability. So if one machine fails, your containers just get automatically restarted on another healthy machine. No downtime. Now, when you start talking about orchestration, there are really two big names that dominate the conversation: Docker Swarm and Kubernetes. Docker Swarm is Docker's own native solution, and it's all about being simple and easy to use. Kubernetes is the incredibly powerful industry-standard system that originally came from Google. You can think of it like this. Swarm is great for getting started, and Kubernetes is for when you need ultimate power and flexibility. Both are fantastic for running your apps in production at scale. So you're kind of at a crossroads here. You can take the blue pill and just stick with the old way with all its familiar frustrations. Or you can take the red pill and get ready to explore this amazing new world of containers. It's definitely a different way of thinking, but it's one that brings incredible benefits in speed, portability, and scale. And that's really the ultimate takeaway. Docker isn't just a better way to package or jar files. It's a fundamental shift in how we build, ship, and run our software. It gives all of us a common language and a common tool set that works everywhere, from your laptop all the way to the cloud. It's a new level of efficiency for you and for your team. So really, the question isn't if you should start using it, it's what are you going to build with it first.